Good afternoon, guys. Um, Today's discussion A deals with a study conducted by University of Hawaii on cognitive health in older adults. So here we go with the presentation I made for you. Sit back and enjoy, please. Here's a concise summary of the key findings from the University of Hawaii study on cognitive health in older adults. Main insights: activity matters. Engaging in work, volunteering, and leisure activities like word games, computer use, and socializing supports cognitive health in aging. Genetics plays a role. The benefits of these activities vary depending on whether someone carries the APOE4 allele, a genetic risk factor for Alzheimer's disease. For those without allele, part-time work and high-intensity volunteering were especially beneficial. For those with the cognitively stimulating activities still helped promote brain health, showing that lifestyle factors can offset genetic risks. Equity and access. The study emphasizes making these activities accessible to diverse populations to help reduce the impact of Alzheimer's and other dementias. Research details. Led by Yon Jung Jane Lee from the Thompson School of Social Work and Public Health, based on data from over 7,600 participants in the health and retirement study. Published in the Journal of Alzheimer's Disease Reports. This research aligns beautifully with your passion for culturally responsive participatory aging interventions. If you're thinking about adapting this into a toolkit or outreach framework, I'd love to help co-design something actionable. Absolutely. The study you're referencing refers a nonsense look at how genetics, specifically the presence of the APOE4 allele, interacts with lifestyle to shape cognitive health in older adults. Genetic risks. APOE4. The APOE4 allele is a well-established genetic risk factor for Alzheimer's disease. Individuals who carry this allele are more susceptible to cognitive decline, but the presence of the allele doesn't guarantee poor outcomes. It simply increases risk. Lifestyle is a buffer. The study found that cognitively stimulating activities like word games, computer use, and social engagement can offset some of the genetic risk. Even among those with the APO4 or APOE4 allele, these activities were linked to better cognitive outcomes, suggesting that modified behaviors can mitigate genetic vulnerability. Stratified findings. For people without the APOE4 allele, part-time work and high intensity give me 1 second. Volunteering had especially strong cognitive benefits. For those with the allele, the protective effects of cognitively engaging activities were still present, though the types of activities that helped most may differ. Implications for intervention design. This reinforces the importance of tailoring cognitive health interventions not just to cultural and social context, but also to genetic profiles without making them exclusionary. It's a compelling case for equitable access to enriching activities, especially in communities disproportionately affected by dementia. Would you like to explore how this could inform a culturally adaptive toolkit or outreach strategy? I'd love to help co-create something grounded in both science and lived experience. For individuals carrying the APOE4 allele, which increases susceptibility to Alzheimer's disease, the research highlights several non-pharmacological interventions that can help buffer genetic risk and promote cognitive resilience. Cognitively stimulating activities, word games, puzzles, and brain training apps. Computer use for learning creatively or social connections. Reading and writing, especially when tied to storytelling or culturally memory, these activities help maintain neural plasticity, and may slow cognitive decline even in genetically at risk individuals. Social engagement, group discussions, clubs, or community events, integrational programs that foster mentorship and storytelling, culturally tailored social activities that resonate with identity and values. Social interactions is a powerful cognitive stimulant and can reduce isolation, which is known risk factor for dementia. Pur- Purposeful work and volunteering. Part-time employment with cognitive demands, e.g., planning, problem solving. High-intensity volunteering, especially roles that involve leadership or teaching. These were shown to be especially beneficial for those without the APOE4 Ali, but still offered protective effects for carriers. Lifestyle and wellness. Physical activity, e.g., walking, Tai Chi, dance, supports brain health via improved circulation and reduced inflammation. Nutrition, rich in omega-3s, antioxidants, and polyphenols. Think Mediterranean or Okinawan diets. Stress reduction through mindfulness, spiritual practices, or nature in immersion. Design implications. Interventions should be culturally responsive to ensure relevance and uptake, accessible and inclusive, especially for marginalized communities. Adaptable and genetic profiles without stigma, stig, stigmatizing or excluding. This opens the this opens up exciting possibilities for co-designing toolkits that integrate genetic awareness with participatory, community driven strategies. Want to sketch out a framework together? I'd love to help you build something that bridges science, equity, and lived experience together. Absolutely. The interplay between genetics and lifestyle is one of the most promising frontiers in cognitive health. And the recent findings from the University of Hawaii study offers compelling evidence that genetic risks is not uh, destiny. Genetic risk, APOE4. Carrying the APOE4 increases susceptibility to Alzheimer's disease. Its effects, it affects how the brain processes lipids and clears amyloid beta, contributing to neurodegeneration. However, this risk is modulated by environmental and behavioral factors, meaning lifestyle choices can either amplify or buffer its effects. Lifestyle as a protective force. The study highlights several lifestyle domains. That can contribute or that can counterbalance genetic vulnerability. Cognitive engagement. Activities like word games, computer use, and reading stimulate neural networks. These help maintain cognitive reserve, which can delay the onset symptoms even in genetically at-risk individuals. Social interaction. Regular socializing reduces loneliness and stress, both of which are linked to cognitive decline. For APOE4 carriers, social engagement may help regulate inflammatory responses and support emotional resilience. Purposeful activity. Part-time work and high-intensity volunteering, especially leadership or teaching roles, were known to enhance cognitive outcomes. These activities promote executive function and provide structure, which is especially beneficial for those without the allele, but still protective for carriers. Physical wellness. Exercise improves blood flow, reduces inflammation, and supports neurogenesis. Diets rich in omega 3s, antioxidants, and polyphenols, like the Mediterranean or Okinawan diets, help combat oxidative stress and support brain metabolism. Mindfulness and nature immersion reduces cortisol levels, which can otherwise exacerbate genetic vulnerabilities. Design implications. This evidence supports a precision public health approach. Interventions should culturally adaptive, inclusive, and tailored to genetic profiles without stigmatizing individuals. It's about empowering choice, not labeling risks. Okay, if you're thinking about integrating this into a toolkit or outreach model, we could co-create a framework that blends genetic literacy with participatory, community-driven strategies. Want to sketch out a few pillars together? Diet plays a powerful role in modulating genetic risk for Alzheimer's, especially for individuals who carry the APOE4 allele, the strongest known genetic risk factor for late onset Alzheimer's. Here's how nutrition intersects with genetics to influence brain health. Okay, anti-inflammatory and antioxidant effects. Diets rich in omega-3 fatty acids, polyphenols, and antioxidants help reduce neuroinflammation and oxidative stress, two key pathways through which APOE4 contributes to cognitive decline. These nutrients support cell membranes integrity, synaptic function, and amyloid beta clearance, which is all of which are composed in APOE4 carriers. Protective dietary patterns. The Mediterranean diet, high in fruits, vegetables, whole grains, fish, and olive oil, and Okinawan diet, rich in sweet potatoes, tofu, and sweetened and seaweed, have been shown to improve vascular health, which is critical for brain function. Support glucose metabolism, which is often impaired in APOE4 carriers. Lower levels of homocysteine, neurotoxin, amino acid linked to dementia. Gene diet interactions. APOE4 carriers may respond differently to dietary fats. Saturated fats found in processed foods, red meat, may exacerbate cognitive decline in carriers. Unsaturated fats from fish, nuts, and seeds appear to have protective effects, especially when combined with other brain healthy nutrients. Precision nutrition implications. For those at genetic risk, personalized dietary interventions can be powerful tools for prevention. Culturally tailored nutrition programs, especially those that integrate traditional focus and community practices, can enhance adherence and impacts. This aligns beautifully with your work. If you're thinking about integrating dietary guidance into a cognitive health toolkit or outreach model, we could co-design something that blends genetic literacy with culturally responsive nutrition strategies. Want to sketch out a few pillars together? Different diets can significantly influence the risk of developing Alzheimer's disease, either by amplifying genetic vulnerabilities or by offering protective effects that support brain health. Here's a breakdown of how key dietary patterns impact Alzheimer's risk. Protective diets. Mediterranean diet, rich in fruits and vegetables, whole grains, legumes, fish, and olive oil. associated with reduced inflammation, improved vascular health, and slower cognitive decline, supports glucose metabolism, and lowers homocysteine levels, which are especially beneficial for APOE4 carriers. Mind diet, Mediterranean DASH intervention for neurodegenerative delay, combines elements of Mediterranean and DASH diets, emphasizes leafy greens, berries, nuts, whole grains, and lean proteins, linked to a significantly lower risk of Alzheimer's. Even the modest adherence shows benefits. Okinawan diet. High in sweet potatoes, tofu, seaweed, and vegetables. Low in saturated fats and calories, rich in antioxidants and polyphenols. Promotes longevity and cognitive resilience, especially in aging populations. Risk enhancing diets. Western diet, high in processed foods, red meat, refined sugars, and saturated fats, associated with increased inflammation, insulin resistance, and oxidative stress. May exacerbate cognitive decline, particularly in individuals with genetic risk factors like APOE4. High glycogen or high glycemic diets. Diets that spike blood sugar, sugary drinks, ripe white bread and pastries, linked to impair insulin signaling the brain, which can accelerate neurodegeneration. Gene diet interactions. APOE4 carriers may be more sensitive to dietary fats. Saturated fats can worsen cognitive outcomes. Unsaturated fats from fish, nuts, seeds may offer neuroprotective effects when combined with antioxidants. Cultural and equity considerations. Culturally tailored nutrition programs that integrate traditional foods and community practices can improve adherence and impact. Precision nutrition, especially when adapted for diverse populations, can empower individuals to make informed choices that align with both genetic and cultural contexts. If you're thinking about integrating this into a participatory kit or outreach model, we could design a framework that blends dietary guidance with genetic literacy and cultural relevance. Want to sketch out a few pillars together. Okay, guys, so that is A for you. I will be back on shortly for B. Give me a bit to be on for B because I have to put it together for you. For now, Gator Wellness. Take care, folks.